Hello everyone, my name is Santosh Satyaseelan and my metric card number is 01DEE24F1141 and I am from DEE 3E. Today I will be presenting practical work 2 entitled Diode as a Rectifier and Clipper. A diode is a semiconductor device that allows current to pass only in one direction. It is made by combining P-type and N-type materials forming a PN junction. The two terminals are called the anode and cathode. In forward bias, current flows, and in reverse bias, it blocks. This simple behavior is essentially in many circuits, especially for converting AC to DC. The objective of practical work 2 is, at the end of the lab session, students should be able to observe diode application as a switch during forward and reverse bias connection. To construct the obtained output waveform of a rectifier circuit by using half-wave rectifier and bridge rectifier. And now I am going to explain about rectifier circuits. And for first is half-wave rectifiers. Half-wave rectifier during the positive half cycle. During the positive half cycle of input AC voltage, M is positive and the diode D is forward biased and conducts. While conducting, diode acts as a short circuit so that circuit current flows. Positive half cycle of the input AC voltage is dropped across RL. The output waveform is similar to the input voltage waveform. After that, half-wave rectifier during the negative half cycle. During the negative half cycle of input AC voltage, point M becomes negative and the diode is reverse biased, so it does not conduct current. Diode acts as open circuit, so there is no current flow. There is no voltage drop across RL. The negative input half cycle is suppressed. And the second one is full wave rectifier. When input AC supply is switched on, the ends M and N of the transformer secondary becomes positive and negative alternately. When terminal M is positive, G is at zero potential and N is at negative potential. Diode D1 is in forward biased and D2 is in reverse biased. Current flows along M, D1, C, RL and G. As a result, positive half cycle of the voltage appears across RL. After that, when terminal N is positive, G is at zero potential and M is at negative potential. Diode D2 is in forward bias and D1 is in reverse bias. Current flows along N, D2, C, RL and G. As a result, positive half cycle of the voltage appears across RL. Now I am going to explain about clipper circuit. Clipper circuit is functioning to clip or remove the unwanted part of an input wave in a circuit. A basic clipper circuit contains a resistor and a diode. You can refer the figure to identify negative series clipper, positive series clipper, negative shunt clipper and positive shunt clipper. And this is the figure for series clipper operation. When negative series clipper, diode is forward biased during the positive alternation of the input signal. And when positive series clipper, diode is forward biased during the negative alternation of the input signal. And this is the figure for shunt clipper operation. When positive half cycle operation, positive alternation, reverse bias in D1. reverse bias diode acts as an open. And when negative half cycle operation, negative alternation, forward biased in D1, forward biased diode acts as a short. Okay, let me show you how to create a half waveform and a full waveform. First, connect channel 1 of the oscilloscope by attaching the probe to the positive terminal of the BJT and the negative terminal of the resistor. Then connect channel 2 of the oscilloscope by attaching the probe to both the positive and negative terminals of the resistor. Next, connect the signal generator by attaching its probe to the positive terminal of the BJT and the negative terminal of the resistor. This is how we obtain a half waveform. To create a full waveform, take channel 2 of the oscilloscope and clip it to the negative terminal of the resistor. Then take the positive probe from the transformer and clip it to both BJTs. Do the same with the negative probe from the transformer. Connect it to both BJTs. Finally, adjust the trigger level so that the waveform is stable and does not shift, allowing you to get an accurate reading. And that is how you obtain a full waveform. In this experiment, we successfully studied how diodes function as rectifiers and clippers in electronic circuits. We observed that a half-wave rectifier uses a single diode to convert only the positive half of the AC signal into DC, blocking the negative half. A clipper circuit uses diodes to remove specific parts of a signal's voltage, either the positive, negative, or both based on the configuration. This is useful for protecting components or shaping signals. Importance of diodes in electronic circuit design is waveform shaping. In signal processing, clipper circuits using diodes are used to limit voltage levels. They protect circuits by cutting off unwanted high or low voltages, and is also used in audio systems, communication transmitters, and waveform generators. Number 2, voltage regulation and protection. Zener diodes regulate voltage in power supplies. Flyback diodes protect circuits from low voltage spikes in inductive loads like motors and relays. It also prevents damage to sensitive components like transistors and ICs. Number 3, switching applications. Diodes act as fast electronic switches in digital logic circuits. It also used in logic gates, microcontrollers, and timing circuits. And the last one is signal demodulation. In radio receivers and communication systems, diodes extract audio or data signals from high frequency carriers. It is also important in AM and FM radio and wireless communication. In summary, diodes are one of the most essential building blocks in electronics. Whether it's converting power, shaping signals, or protecting sensitive components, they are critical in both basic and advanced circuit designs. And that's the end of our practical work 2 on diodes as rectifiers and clippers. I hope this video helped you understand how diodes control current flow and how they are used in real-world circuits like rectifiers and clippers. If you found this video useful, please like, share and subscribe to my channel for more educational content. Got questions or need help with your own experiment? Drop a comment below. I'd be happy to help. Thanks for watching and see you in the next video.